Have you ever been in this situation that you want to perform a certain action, that you want to execute a file or change a setting, and you just got the error message, you're not allowed to do this action. You're not authorized to execute this file, or you don't have the permission to change this configuration. Yes? Did you get angry? Then this is exactly the talk for you. Welcome to, well, that escalated quickly, a penetration tester's approach to privilege escalation. But before diving into the topic, I would like to know a little bit more about you guys. Who of you is a penetration tester? Please raise their hand. Okay, some, not that many. Do we have security researchers? All right. Do we have system or network administrators? Some of you, great. Another question. How many of you guys use a disk encryption tool like BitLocker? Not all, okay. And of you guys, how many have to enter their password every time they boot their PC? Okay, that's good, because it's going to be interesting later on. So, as a penetration tester, sometimes during our assessments, we get access to a system. However, only with a low privileged user. But we want to do everything that we want. We want to execute any file, we want to change any configuration file, we want to intercept the network traffic. But we cannot do this with our low privileged user. And that's exactly why we need to escalate our privileges. We want to escalate our privileges to be fully operative. So it is a very important task in an assessment within a penetration test, but sometimes it gets really complex and complicated. It's not always an easy task. Sometimes it might be, but it does not necessarily have to be. So that's why we want to know more about privilege escalation. And if you search in the internet for privilege escalation articles and tutorials, you will find some things. You will find some very specific tutorials or articles, and some that are written in a more general way. However, there is not really a comprehensive and profound literature that deals with this topic. And that's why I chose to research this topic. So what do we want to achieve? We want to learn the theory and the practice of privilege escalation attacks, so that we can use it in our daily life. Whether we are a penetration tester and we are attacking a system, or whether we are on the other side and trying to defend our systems. And at the end of the talk, we want to have a practical and systematic approach for every one of us who wants to escalate his privileges. In this talk, I am going to focus on Windows systems, but the concepts that you're going to learn can be used for other operating systems or even other systems or applications. So we have to talk a little bit about Windows and its basic components. Windows is the de facto standard in the company networks. Most companies, most big companies, most banks use Windows as an operating system for their employees' computers, laptops, and workstations. It holds a market value of over 80%, so it's the dominant operating system. And also, in company networks, we find more and more Windows servers. Windows itself is complex. So it's an operating system that's old, that's long on the market. Many vulnerabilities have been found, and many vulnerabilities have been patched. And this all together adds into the complexity of Windows systems. And obviously, what we always want to achieve on a Windows system is to get administrator or system privileges, which are the highest privileges in Windows systems the equivalent to the root account in Linux. So one of the most important components of Windows is the registry. The registry is built in a tree structure where you have a root key at the top. The highest level keys are called root keys, and it consists of keys and values. And every key that has another key, or every key that is under another key, is called subkey. So as you can see on the right side of the slide, we have the 5 root keys of a Windows system. What does the registry store? Amongst other things, it stores system-wide software settings. It contains the security database. So all the user passwords are stored in the registry. Not everyone can access it. You can only access it with system privileges, but this is where it is stored. And also it contains per user configuration settings. So if you have more than one user, or even if you have only one user, the settings that are specific to this user are also stored in the registry. The registry itself is protected by an access control list. So for every key, you can have a different ACL. Another important aspect of Windows systems are processes. A process, in simple terms, consists of a process ID, an executable program, and a security context. So a security context are mainly security tokens, also called access tokens, and it contains information about the user, the security group, and the privileges of the process. Now that we know more about processes, what are jobs and threads then? Jobs are simply groups of processes. So as you can see on the screen, you have the process cmd.exe, and this process again contains 2 other processes, conhost.exe and notepad.exe. And threads are entities within a process that are computed by the CPU. Services is another very important component of Windows. What are services? Services are processes that start at system startup. So every time you boot your PC, different services are started, and these again start load processes, which again contain an executable file. So every service also has an executable file. And these services run in the context of a certain user, meaning that every service can have a certain user in which with the privileges of a certain user which the service can use. Most of the accounts that are used for services are non-interactive accounts, so-called service accounts, which we'll talk about shortly. And normally, or most services only just run in the context of a system user, so with the highest privileges in the system. Windows offers 3 different service accounts. First of all, the local system account, which is also called the system account. It is, as we said, it has the highest privileges on the system, and you can do everything with this account. Although some privileges are not enabled by default for the system account or the local system account, you have the privilege to enable other privileges. So eventually you can have every privilege out there. And yeah, most core Windows components run under the system account. So if you would find a vulnerability in such a Windows component, then you will directly have system privileges. The second account is the network service account. This also contains high privileges, less than the system account, but still high privileges. And what the network service account is used for is to authenticate against other network services. And then, last but not least, we have the local service account, which has the same privileges as the network service account, except that you cannot use it for authenticating to other network services. And the last two things that are important are startup programs and scheduled tasks. So startup programs and scheduled tasks are very similar to services. The difference between startup programs and services is that services are managed by the service manager, while startup programs are not. And scheduled tasks are processes that run at a certain time or after a certain period of time. Yeah, and both of these run again, in the context of a certain user. So what we want to do in the later stages, we will find out more. We want to attack those startup programs and those scheduled tasks that run in the context of a high-privileged user. That's it about the Windows components. Let's dive into the different privilege escalation methods and techniques. So, just as an overview, as we said, there are things in Windows that are similar to other things. There are components that are similar to other components, and that's why some attacks and some methods may be used not only for one component, but for several. And what I did is to create attack trees. These attack trees can give an overview to you on which attacks you can perform and which different conditions have to be met. So the first big attack tree, and you have to imagine this is the part of a very big attack tree, is insecure services. So in this part of the attack tree, we want to attack insecure or misconfigured services. And as you can see in the second row, we have five different techniques. The first one is weak service executable or configuration file permissions, unquoted service paths, weak service permissions, DLL hijacking, and weak registry key permissions. As you can see in the third row, for instance, for unquoted service paths, we have again two conditions, and we will talk about it in the next slides. So the first method or technique is the weak executable file permissions. So as we said, every service has an executable file that it runs. What we could try to search for is to find an executable file that runs in a high privileged service that we can modify. So as you can see in the blue figure, the service is called Waves Sys SVC, which is a sound manager tool for Dell laptops, and it runs under the local system account, so the highest privilege. I don't really know why a sound manager tool needs system privileges, but hey, it's good for us. And in the fourth row, you can see we have the right attributes, and every user of the group built-in users can modify the file. So we, with our low privileged user, can go ahead and just modify or replace the file and put in our malicious code. The next time this service is started, our malicious payload will be executed with system privileges. How do we restart the service? We could either reboot the system, or we could, if we have the privileges, use the SC tool to restart the service. Another interesting method, the unquoted service path method. For the unquoted service path method, what you need are services that use a file path which does not contain a double quote, so no double quotes at the beginning and at the end, and that contain a white space somewhere in the file path. So as an example, we have C/program, white space, files/waves, etc. So both conditions are met in this example. What does Windows do? And this is something very weird. I don't really know why it does it, but it is how it works. it tries to execute the file c/program.exe. What does this mean for us? It means if we have write permissions to the C directory, we could just create our own program.exe file, and then the next time the service is loaded, our malicious file will be executed instead of the file that is defined in the file path. And I was kind of shocked when I noticed that my previous Dell laptop that I got had exactly this vulnerability in it. So this is how I got it from Dell, and it contained a service for this WaveSys SVC service, which is also a sound manager tool, and it didn't contain any quotes at the beginning and at the end. And the same applies for Lenovo and ThinkPad. Some years ago, they had this vulnerability. Another very interesting but a little bit complex attack and technique is called DLL hijacking. So applications that are started normally try to run DLL files at runtime or load DLL files at runtime. If the DLL file is missing, meaning it tries to load a DLL file that does not exist, and it uses a relative path and not an absolute path, then we might have a vulnerability. So what does Windows do if a DLL file is missing? It tries to search for the DLL in certain folders. It starts with the applications folder, then goes to C Windows System 32, C Windows System, C Windows, and then the current working directory. And after that, it searches for the DLL file in all the directories that are in the system path variable. So, and this is exactly where we could try to find a bypass, or where we could try to find an exploit. If we go through all the directories that are defined in the system path variable, and we find a directory where we have write access to, then we can just write our own file, our own DLL file into that directory, and the next time the program is started, it will load our malicious DLL file. That's it about services. Just a quick glimpse into startup programs. Startup programs, as we said, are similar to services, and that's why we have 3 techniques that also apply for insecure services. And the same applies for scheduled tasks. For scheduled tasks, as we all know, a certain time period has to pass by, or a certain time, or scheduled tasks are executed at a certain time. What can we do if this, do we have to wait until this time really, until this time happens, or until this time comes? No, we probably don't have to do. What you could try is to just change the system time, if you have the privilege to do that. So you would change the system time to the time the scheduled task will be executed, and then it will be executed immediately. One very obvious, but probably very successful method is to exploit outdated software. So you have 2 kinds of software that you would want to exploit. First of all, you want to exploit software or vulnerable software that runs with high privileges, and you want to exploit the Windows kernel if possible. Why the Windows kernel? Because if you exploit the Windows kernel, you will have system privileges right away. Why is this very successful? Because companies mostly are very slow in deploying patches. Maybe because they have many different systems, or maybe they have very critical systems that need to be tested, or where the patches have to be tested before they are deployed into production. And this opens the gap for us attackers. Also very obvious, weak passwords, but I will tell you a story shortly. So what you could have, you could find you will gain access to a system which has a web server, and this web server connects to a database. So what you will do is to search in the web server directories for the password of the database, for the user password. And some administrators use the same password for everything they do. So this would be a very simple technique to just try this, to just take the password and try it for the login of the administrator account or the specific administrator account. Also, you could try wordless attacks or brute force attacks, as we all know. What sometimes happens is that besides the database configuration file, that you will find plaintext passwords in Windows configuration files or in Windows XML files. So these are some paths where you would might find a password. And once I was in an assessment for a big German bank, and I had the task. I got an employee laptop, and I had the task to find a way to escalate my privileges. So I tried all the hard stuff. I tried it with the DLL hijacking, unquoted services path, and I tried many different things, but I didn't really find a way to escalate my privileges. So what I thought is maybe I'll try just the easy things. And I searched for plaintext passwords, and tada, I found a password. And this password was not only used for a local user or local administrator, it was used for the domain admin. That means with this password that every employee of the bank has on his laptop, he could directly access the CEO's laptop, he could access the administrator laptops. It is a very, very low-hanging fruit. So yeah, such stuff happens. So don't only go for the complex things, also go for the low-hanging fruits. And besides files, you could also find passwords in the registry. So for instance, if auto login is enabled in Windows, you might find passwords there also. Another possibility is if we have physical access to a machine, be it a laptop, computer, or a server, then we could try other attacks. So first of all those of you who do not use disk encryption, use disk encryption. Why? Because if I get access to your laptop, I can just boot my own Windows CD, replace some files in your file system, and the next time I boot up your machine, I will have system privileges and have access to your machine. So it's a very easy thing, and it's widely known. However, if you use disk encryption, but you do not have pre-boot authentication. What is pre-boot authentication? Pre-boot authentication means that whenever you start your laptop, that you have to enter your password which is used for the decryption of the volume. If you do not use this, meaning that the decryption key is stored somewhere on the motherboard and is loaded into the memory when starting the machine, this means that an attacker could try to extract the decryption key from the memory. And there are many attacks that were performed in some research universities, and they were able to successfully dump the memory and extract the decryption key and then access your machine. And if you have the decryption key, I can again do the same technique. I can just replace some files on your machine and then have system privileges. Another possibility would be attacks against CPU microcontrollers. We all heard of Spectre, we all heard of Meltdown, and although no proof of concept was published, it might be possible that out there in the wild someone has some exploit which executes some malicious code on your Intel or AMD microcontroller. So in the beginning I asked you who of you uses disk encryption and who of you uses a password. If you use a password, that's already very good. But nevertheless, if you use disk encryption, 3 days ago there was a new research published by a Dutch university which showed that many hardware encrypted devices are vulnerable. That's why if you go home, try this command with administrator rights and check whether you have a software encryption or whether you have a hardware encryption. If you have a hardware encryption, it might be possible that you are vulnerable. So we learned a little bit, some techniques and methods. There are many more out there. If you're interested, come to me after the talk and we can talk. But one very important thing is, I know there are so many different methods and so many techniques. How do I apply them? How can I have a structured and practical way to use them in an assessment, for instance? And that's why we need a practical and systematic approach. This is how the approach looks like. We have 3 different phases. The first phase is the general information gathering phase. The second phase is the method and technique iteration, where we again have 4 different steps. And as you can see, we stay in phase 2 because we iterate through the different methods. We'll talk about it shortly. And in phase 3, we have the reporting phase. So in phase 1, what we really want to achieve is to get a good overview of the system. We want to know which Windows version is it. We want to know which CPU architecture is used. We want to know which service pack is used. We want to know about network devices and interfaces, and so on and so forth. So we want to learn more about the system in general. After that, we will go into phase 2. In phase 2, as I just said, we will iterate through the different techniques and methods. And you can choose the techniques and methods according to your goal. For instance, if you have an assessment where the goal is to find as many privilege escalation possibilities as possible, then you could start with the more complex ones. If you have the goal to just get to escalate your privileges and then attack other systems, you could choose the most easiest one or probably the most successful ones. And yeah, as we said, every iteration consists of 4 different steps. In step 1, we have again a small information gathering phase or information gathering step. What we want to achieve here is to find out, is the system vulnerable against the technique that I want to use? For instance, if we want to check for unquoted service paths, then we will check every service for an unquoted service path. If the system is vulnerable, we will go to step 2. In step 2, we will conduct our research and we will develop our exploit. So we want, for instance, if there is an outdated software, we want to gather everything about the system. We want to know more about the exploit, understand the exploit, and then maybe customize our exploit according to our system. So we have to know which architecture is used and which service pack and so on and so forth. Sometimes it is necessary to set up a test environment. Why? Because some services can be exploited only once. And if the exploit fails, the system crashes. So you want to be sure that your exploit works. And that's why it would be good to set up a test environment that is very similar to the target system that you're attacking. Also, you should consider possible security mechanisms. So let's say, is there an antivirus software in the PC? If there is an antivirus software, then we have to apply different evasion techniques and modify our payload so that the antivirus system does not detect it. Also, if we use a payload that builds a reverse TCP shell, do they use a firewall? And if they use a firewall, which ports are most likely to be open? Port 443. So or port 80. So these things are dependent on the environment. So these things should be considered when you develop your exploit. In step 3, we want to test our exploit. So we use our exploit. Sometimes it works right away, but in most cases you will have to go back, and see what failed, check again, rebuild your exploit, and then test again the exploit until eventually it will hopefully work. And in the post-exploitation phase of every technique, you should document every step and every result. And also, you could check with the system administrators or network administrators, hey, I just escalated my privileges. Did you notice anything? Because this is very valuable for companies. Sometimes companies pay millions for different security software systems, and in the end they don't even work. And this is valuable information for them. So yeah, we go through every technique and every method that there is. And in phase 3, it's the reporting phase. As in every penetration test, any vulnerability should be reported independently on whether it worked or it didn't work. Sometimes you have a vulnerable service, but you cannot exploit it because you don't have the time or because of other things. Nevertheless, you should report it, should document it so that the customer can patch or fix the vulnerability. Also, passwords and sensitive data should always be censored, so you don't know who will get access to the report. And you don't want the domain admin password to be known to everyone, right? Also, sometimes what could happen is that you get access to a system and notice, hey, someone else was already on the system, like there was another exploit already in some folder or something like that. And if this is the case, you should immediately contact the customer and then discuss how to go with it. And also, always document all the exploits that you used and the uses that you added, because they should be removed. And if you can remove them yourself, then this would be the best case. So this is the approach. There are some tools which we can use to simplify the approach. So I mentioned 4 tools. There are many more out there, but you could conduct your own research and try them out. I found these 4 very useful from my experience, but yeah, just try them out and check whether they're good for you or not. So the first one is obviously Metasploit. Metasploit comes with a lot of enumeration tools and methods which you could use in a Windows environment. Also, another very powerful tool is PowerSploit. So let's say unquoted services path or the weak service executable file permissions. There are scripts which do the research for you, so you don't have to do it yourself. Also, there is a tool called broot, which is similar to PowerSploit, not that powerful, but also fulfills its purpose. And you have the Windows Exploit Suggester, which you can use to, you will first dump the last applied patches on the system, and then use the Windows Exploit Suggester to find out whether the latest patches have been applied or whether there are patches missing on the target system. So, to conclude, what we have just learned can not only be used by penetration testers, but also by network or system administrators, by architects who build Windows systems. And generally speaking about Windows, Windows offers a great number of security mechanisms. So we have many different security tools that you can use. You have a very granular configuration of accesses and privileges. As we just saw, you could apply an ACL for every single registry key. And also, in most cases, patches are deployed in a fast manner. So it doesn't take Windows too long to publish exploits. I know there are exceptions, but this is the normal case. So hopefully we have learned things about Windows, about privilege escalation methods and techniques, about an approach that we can use during our assessments, and tools that we can then use. And the next time, I'm sure this will be you well, that escalated quickly. Thank you, everyone.
All right, thank you so much, Khalil. So we have our first question. So he is the first. I will give you.
Can I ask two questions?
Sure.
Cool. So, in the exploit regarding the unquoted path, you said that Windows first looks for C double dot slash slash program dot exe. Is that generally true, or does it look for any kind of program after the before the first space? Like if you had C dot dot slash slash Facebook stuff, does it look for facebook.exe?
If there is a white space after it, it does look for facebook.exe.
Cool. And the second question would be, Windows comes with some preloaded and predefined services you can't really stop. If they don't patch that service, what do you do? I mean, there's going to be an exploit in your system that you're going to know about. Can you mitigate that?
Oh, that's a tough question. So from a defender point of view, you would have to hope for Windows to patch the system. That's if you cannot change the service, you cannot disable it, then very hard. What you could try to do is to find other security tools or like antivirus software or something like that, which explicitly looks whether this file is replaced or whatever the attack is. So this is maybe something that you could do on another layer. So you just like virtually patch this vulnerability. But to have a really fix the root cause, you would have to wait for a Windows update. But one very interesting thing is that attackers, normally not penetration testers, what they could just do if they have access to a Windows system and they are not able to escalate their privileges, just build a backdoor connection and wait some months. Because from time to time, kernel exploits are published. And most companies will not notice a backdoor into their system. So you just wait until the next exploit comes out, and then you can escalate your privileges.
Okay, thank you.
Yeah, you're welcome.
Thank you, sir.
There's
We had another one. Yeah, there. So he was the second, sorry, sir. Please.
This is the easy one. You can answer with yes or no. Did you find any way to exploit the Spectre vulnerability?
No.
Thanks.
Yeah.
So we have another one here.
Hi. I'd like to know, in real life, how long does it take to go through the whole process of scanning the computer and including extending your exploits and customizing them for the target machine? Because in real life, once an attacker has physical or remote access to a computer, well, he kind of won already.
I don't really know where you are, but there. Great. Sorry. How long does it take? It depends. Sometimes it can take minutes, hours, or even weeks. So those of you that did the OSCP certificate or want to do it, you will get to know what I mean. Sometimes you will find it right away, and sometimes you have to enumerate. You don't find anything, and then you have to take a step back, and again, search through the system, gather information, and then hopefully, eventually, you will find it.
Thank you.
So, how common is the unquoted service path vulnerability? Because developers, I guess if they put unquoted paths, they should be able to notice that their service won't start when testing, no?
It should start. I mean, unquoted service paths only means that Windows, additionally to the file you have defined, tries to load other files where the white space is located. So if there is not such a file, Windows continues to go through the path. Every white space it finds, it will try to execute the file. But if there are no more white spaces, it will execute the file that you want to use.
Okay, so first it tries till the first white space and doesn't find anything, then it
Exactly.
continues to.
Exactly, yes.
All right, thank you.
So you might find you might find a white space, or you might find two white spaces where you, at the first white space, cannot write a file, but at the second white space. So this is also possible.
Okay, thanks.
You're welcome.
We have another one here.
Hello. One question about the inception. When you think that Windows will solve this problem, and not only Windows, that can use to escalate the privileges in Windows, Mac OS, Unix, everyone. And I even saw that lately adopted also one module from Metasploit instead of the inception for can create reverse vectors for connect. Thank you.
Sorry, I didn't get the question. What was the question? Sorry?
When you think will be solved this problem, or because it's 4 years more?
Yeah, I think it will be never solved, so it will be always a race between hackers and defenders. I mean, you have to imagine an operating system is not a small program. It contains of millions of lines of code, not even much more. And you cannot ensure that every developer knows what he does and does everything in the correct way. And sometimes it's not even the Windows developers, but it's also software that you as a company install on your employees' laptops, or a misconfiguration. So, in my opinion, it will never stop.
Okay, thank you.
You're welcome.
Things. Okay. There, I'm coming. Yeah.
So I got a question regarding the password. Should we use better passwords, or is there a recipe for how we can secure our networks or our computers? By which I mean to say, is there a clear recipe that we can apply on all machines that we can ensure that there's never gonna be a privilege escalation or a possibility of exploit or OPSEC?
So from a defender perspective, there are tools. There is a tool, I don't really remember the name, but what it does, it sets the local administrator passwords on the laptops, and it changes it every 90 days or something like that. And generally speaking, you should always use a password manager and use complex passwords, and only use one password for only one user and not for several users. There are many guides out there which you could apply or implement in your group policies also as Windows administrator, so to say. This way you can ensure it.
Generally, good OPSEC, operational security for the computers.
Yeah, operational security.
Thank you.
You're welcome.
Do we have others?
Yeah.
Okay.
Was there at a certain point in time a default service vulnerability in Windows that could have been exploited to take control of the computers on the whole domain, not just the local PC?
You mean a service in a local PC which you could use to exploit? Good question. So I'm sure there were vulnerable services, 100%. I mean, what you could have is you have a service that you can exploit, and then you get system privileges. And with the system privileges, you could use tools like Mimikatz to get all the password hashes of users that log into your machine. And if there is a domain admin who connects to your machine, you can then extract his password and use the hash attack to connect to the domain controller or other machines. So this is a way that I could imagine you could exploit your escalate your privileges to a domain admin. But directly from the service itself, I do not know any case.
Thank you.
You're welcome.
Regarding the missing DLL exploit,
Yes.
Since the DLL file is missing, shouldn't the app be able to start anyway. So would a user still keep an app on its laptop or desktop that is not able to start? And if the DLL is erased by you as a hacker, shouldn't you already have privileges to exploit or directly modify that DLL5?
Okay, good question. So regarding programs, so Windows or the Windows applications load DLL files at runtime. And if they don't find the DLL file, it does not necessarily mean that the application crashes. Sometimes it does, but not every DLL is necessary for the application to run. So you might have an application, or there are many applications that try to load missing DLL files but are not able to. From a security perspective, it would be great if you could remove such tools, but it will not always be possible. And your second question, if you are able to place your own malicious DLL file, does this not mean that you don't already have high privileges? Not necessarily. So in the first folders that I showed earlier on, I'll just open it again. So in the first four, or in the first 5 folders, you will probably not have write access. Where you could have write access is in a directory that is defined in the system path environment. So in the system path environment, sometimes you have tools like C/Python. And in Python, I think by default you have write access. And if you can write to the Python directory, the DLL file will be loaded from there. That's how the exploit works.
Got it. Thank you.
You're welcome.
Thank you. Are there any other questions? No?
All right, so if you have further questions, you can always contact me via my email or call me directly. And also, after the talk, I'm going to be here and answer your questions. Thank you again for your great questions and the discussion.
Thank you, Khalil.